Richard Feynman once leaned back in his chair. The kind of slow, relaxed movement that only someone completely at ease with uncertainty can make. A small, knowing smile formed on his face. Not the smile of someone about to shock you with drama, but the smile of someone about to gently remove a veil from your eyes. And then he said something that quietly shattered what millions of people believed about electricity. Not with thunder, not with spectacle, but with calm. Electricity, the thing we think we understand so well, the thing that powers our homes, lights our cities, charges our phones, and hums invisibly behind the walls of our bedrooms, is not what you think it is. At first, that sounds impossible. Electricity feels familiar. We use it every day. We flip switches without thinking. We plug in devices without hesitation. We trust it. And because we trust it, we assume we understand it. Most of us grow up imagining electricity as a kind of invisible river, a current flowing smoothly through wires like water through pipes. We picture power plants generating energy that rushes through cables, racing across miles of infrastructure, sprinting toward our homes the moment we flip a switch. The bulb lights because electrons traveled all that way to make it happen. It is a clean, simple, comforting image. And that is precisely the problem. Feynman did not mock this image. He understood why it exists. The human mind craves metaphors. We translate the invisible into something we can see. We turn abstract fields into flowing rivers because rivers make sense. They move. They carry things. They begin somewhere and end somewhere. But then Feynman gently dismantled the picture. When you flip a light switch, electrons do not suddenly race from a distant power plant to your bulb. They do not sprint across miles of copper wire at lightning speed. In fact, the electrons inside the wire barely move at all. Pause there for a moment. They barely move? That sentence feels like a betrayal of everything we thought we knew. If electrons are not racing down the wire, then what exactly turns the light on? What happens in that quiet fraction of a second between darkness and illumination? Feynman invites us to imagine something different. Imagine that the wire in your wall is not empty. It is not a hollow tunnel waiting for electrons to rush through. It is already completely full, packed densely with electrons, shoulder to shoulder, like people standing tightly in a crowded hallway. Now imagine gently pushing one person at one end of that hallway. That person barely steps forward, but they bump into the next person, who bumps into the next and the next. The motion transfers through the crowd almost instantly. And at the far end of the hallway, someone steps forward, not because they ran the entire length, but because the push reached them. That is what happens in a wire. The electrons are already there. When you flip the switch, you create an electric field, a subtle influence that rearranges energy throughout the entire circuit almost instantly. Each electron moves only a tiny amount, but the effect propagates at nearly the speed of light. The light turns on not because electrons traveled miles in a sprint, but because influence traveled through connection. This is where the ground beneath your understanding begins to shift. Electricity is not primarily about movement. It is about relationship. It is not about particles racing. It is about fields interacting. And suddenly, physics feels less mechanical and more alive. We are so accustomed to thinking in terms of objects and motion. Things move, things collide, things push. But the deeper truth of electricity reveals something more subtle. Energy can be transmitted not by dramatic relocation, but by coordinated response. What truly moves through the wire at near light speed is not the electrons themselves. It is the electric field, a pattern of energy that stretches through space and tells charges how to behave. The field changes everywhere along the wire almost simultaneously. The electrons respond collectively, like a whispered command traveling through a crowd. And in that realization, something quietly profound happens, because this idea doesn't just change how you think about circuits, it changes how you think about reality. Electricity is not a substance flowing like water. It is not a river confined to pipes. It is a dynamic interaction between charges and fields. It is a system responding as a whole. And once you see that, the simple metaphor of flowing water begins to feel almost childish. Feynman was not trying to take away simplicity to be cruel.
He was trying to replace a shallow understanding with a deeper one. He believed reality is far more beautiful than our simplified stories, but beauty requires patience, and patience is rare. We prefer easy explanations. We like metaphors that fit neatly into our existing mental models. We are uncomfortable with invisible fields stretching through space. We are uneasy with the idea that what truly matters is not the motion of individual particles, but the structure of the system as a whole. Yet that is precisely where the truth lives, and Feynman, with that gentle smile, was inviting us to look there. Feynman often warned that the most dangerous state is not ignorance. It is the illusion of understanding. We learn words like current and flow, and we assume we know what they mean. The terminology feels concrete. Current flows, electricity travels, power moves, but language can trap us. When we say electricity flows, our minds immediately summon the image of water, and once that image forms, it becomes difficult to see beyond it. The metaphor becomes a cage. Education often simplifies ideas to make them digestible. There is kindness in that. Teachers are not trying to deceive, they are trying to build foundations. But sometimes, in the act of simplifying, we lose the deeper mystery. And mystery is not a weakness in science. It is the doorway to wonder. When Feynman explained electricity, he was not merely correcting a technical misconception. He was teaching humility. He was reminding us that the universe does not owe us intuitive explanations. Nature is under no obligation to match our everyday experiences. The electric field, this invisible structure stretching through space, is not something we can see or touch directly, yet it is as real as the chair you sit on. It shapes the behavior of charges. It carries energy. It defines the architecture of electromagnetic interaction. Beneath the surface of our modern world lies a constant dance of fields and charges, a silent choreography happening everywhere at once. When a device hums to life, when a light fills a room, when a city glows at night, it is not a river of particles racing from point A to point B. It is a coordinated rearrangement of energy across a vast network. And there is something deeply human in that realization. Because we too live in fields of influence. We rarely move far from where we stand, yet our words ripple outward. Our ideas bump into others. Our emotions spread invisibly through social networks. Like electrons in a wire, we barely shift, but the effect of our presence can travel far beyond us. A small push at one end of the system can cause change at the other. Feynman's explanation strips away the arrogance of thinking we have mastered nature. It replaces that arrogance with quiet respect. Electricity behaves according to elegant rules that do not bend to our metaphors. The universe operates less like a machine made of separate parts and more like a conversation happening across space. When you flip a switch, you are not commanding distant particles to run. You are participating in a field interaction that rearranges energy throughout an entire system. And perhaps the most emotional part of this lesson is not about physics at all. It is about perception. How often do we mistake familiarity for understanding? How quickly do we stop asking questions because something feels routine? A light switch becomes ordinary. A wire becomes mundane. A glowing bulb becomes background. But beneath that ordinary surface lies staggering complexity. A world without mystery becomes mechanical, predictable, dull. And a mind without curiosity slowly forgets how to feel awe. Feynman's real challenge was not about correcting a textbook diagram. It was about waking us up. He was asking us to look again, to question the stories we were handed, to replace easy metaphors with deeper truths, even if those truths are harder to hold in the imagination. Because truth expands us. Electricity is not a river, not a race, not a simple flow through a pipe. It is a coordinated whisper across space, a subtle agreement between particles responding to fields. And once you truly understand that, not just intellectually, but emotionally, you cannot flip a switch the same way again. Every click becomes a reminder that reality is layered, that beneath the visible lies the invisible, beneath the simple lies the profound. The light turns on, the room brightens, and somewhere in that ordinary moment, a question echoes. The same question Feynman quietly posed with that gentle smile. Are you satisfied with the easy answer? Or do you want to know what's really going on?